Arab Republic of Egypt Ministry of Education General Secondary Education Certificate Examination, 2012 Second Stage, First Session Physics 3 hours. Question 1. 8. Mention one application for each of the following. Meissner effect. Model answer. Magnetically levitated train. Explanation. Meissner effect. If a permanent magnet is placed over a disk of a superconducting material, the magnetic field due to the permanent magnet establish electric current in the superconducting disk. Then the current in the superconductor generates a magnetic field, which is always repulsive with the external magnet, so the permanent magnet remains hanging in air. Question 1. 8. Mention one application for each of the following. Mutual induction between two coils. Model answer. Electric transformer. Explanation. Electric transformer base idea. Mutual induction between two coils. Function. Step up or down the voltage. Step up transformer, used at power station. Step down transformer, used at distribution area. Explanation. Electric transformer. It consists of two coils, the primary coil and a secondary coil. The two coils are wound around a soft iron core made of thin iron sheets insulated from each other, to minimize the effect of eddy currents and to minimize the dissipated electric energy. When an electric current passes in the primary coil, a magnetic field is generated. 8. Mention one application for each of the following. Pass through the secondary coil. Model answer. Magnetically levitated train. Explanation. Resistance. It is the opposition to the flow of electric current. Resistance can be calculated from the relation, resistance equals potential difference divided by electric current intensity. Or, resistance equals resistivity times length divided by area. Its unit is ohm equals volt/amper equals joule second/coulomb square equals joule/amper square second. Question 1. 8. Mention one application for each of the following. Mutual induction between two coils. Model answer. Electric transformer. Question 1. B. Compare between each of the following. Forward bias and reverse bias for NP junction withdrawing only. Model answer. Explanation. Forward bias connection. P-type is connected to the positive pole, and N-type is connected to the negative pole. The field due to the battery is opposite to the internal field. The depletion area decreases. The resistance of the P-N junction decreases. It allows the current to passes. Explanation. Backward bias connection. P-type is connected to the negative pole, and N-type is connected to the positive pole. The field due to the battery is in the same direction to the internal field. The depletion area increases. The resistance of the P-N junction increases. It does not allow the current to passes. Question 2. Say what is meant by Fraunhofer lines. Model answer. Fraunhofer lines is the absorption spectrum lines of the elements in the Sun. Explanation. Fraunhofer lines. It was found experimentally that when white light passes through a certain gas, some wavelengths in the continuous spectrum are missing. These wavelengths are the same as those which appear in the emission spectrum of the gas. This type of spectrum is called the absorption spectrum. Fraunhofer lines in the solar spectrum are examples of the absorption spectrum of the elements in the Sun, basically helium and hydrogen. Question 2a. What is meant by the effective value of the alternating current? Model answer. It is the value of the direct current which generates the same rate of thermal effect in a resistance or the same power as that generated by the considered AC current. Explanation. The effective value of the alternating current, I effective equals 0.707 I maximum. V effective equals 0.707 V maximum. E effective equals 0.707 V maximum. Question 2. 8. What is meant by the work function of a metal? Model answer. The work function of a metal. It is the minimum energy needed to free an electron from the surface of a metal. Explanation. The work function of a metal. A2 equals h nu c if the photon energy exceeds the value of work function, the electron is freed and the energy difference h nu EW is carried by the electrons as kinetic energy h nu equals h nu C plus. Kinetic energy. Question 2. C. The moving coil galvanometer of resistance 1 ohm gives full-scale deflection when a current of intensity 20 mA flows through it. Calculate 1. The maximum current measured when it is connected to a shunt resistance of 2.7 ohm. 2. Multiply the resistance connected with the galvanometer to convert it to voltmeter of maximum potential difference 1 volt. Question 2. Model answer. Explanation. Question 3. 8. Write down the scientific term for each of the following. The magnetic flux density, which will exert a force of 1 Newton on a current carrying wire of 1 meter length perpendicular to the field when the current intensity is 1 ampere. Question 3. Model answer. Tesla. Explanation. Tesla, F equals BIL sin theta. F equals BIL unit of magnetic field intensity. Magnetic field density is Tesla, Weber per square meter, Newton per ampere meter, kilogram meter per ampere square second, kilogram meter per coulomb second. Question 3. 8. Write down the scientific term for each of the following. The ratio between the energy of a photon and its frequency. Model answer. Planck's constant. Explanation. Question 3. 8. Write down the scientific term for each of the following. The temperature at which the metal's electrical resistance vanishes. Model answer. The critical temperature. Transitional temperature. Explanation. Critical temperature. The electric resistance of a metal is directly proportional to its temperature. When temperature decreases to reaches critical temperature, the electric resistance drops to zero, nearly zero. At critical temperature, the metal becomes superconductor material. Electric current can flow in the superconductor without any causing of heat effect. Electric current can flow in the superconductor even if the potential difference is removed. Question 3. 8. Write down the scientific term for each of the following. The induced current must be in a direction such as to oppose the change producing it. Model answer. Lenz's rule. Explanation. Lenz's rule. When an electric circuit contains a coil is switched off, the induced current will be forward, which increase the time of current to decay. And in case of switching on, the induced current will be backward, increasing the time of current to reaches its maximum value increases the time of growth. Question 3. 8. Write down the scientific term for each of the following. The ratio between the energy of a photon and its frequency. Model answer. Planck's constant. Explanation. Direct current. It is the current at which its direction and magnitude are constant. Alternated current. It is the current at which its direction and magnitude are varied according to St. curve. Question 3. 8. Give reason for each of the following. Photons might hit the surface of a metal without emitting photoelectrons. Model answer. The frequency of the incident photons is less than the critical frequency of the metal. Or, the energy of the incident photon is less than the work function for this metal. Less than h nu c. Explanation. Fraunhofer lines. It was found experimentally that when white light passes through a certain gas, some wavelengths in the continuous spectrum are missing. These wavelengths are the same as those which appear in the emission spectrum of the gas. This type of spectrum is called the absorption spectrum. Fraunhofer lines in the solar spectrum are examples of the absorption spectrum of the elements in the Sun, basically helium and hydrogen. Question 4. 8. Choose the correct answer from those between brackets. In the shown electric circuit, on closing the key, The reading of the ammeter increases, decreases, doesn't change. Model answer, increases. Explanation. Parallel connection. When electric resistance connected in parallel to electric wire, the wire is considered of zero resistance. Since the electric current is inversely proportional to the resistance, then the current that passes through the wire will be maximum. It means that there is no current passes through the resistor, and it considered as if it is not a part of the electric circuit. Explanation. Backward bias connection. P-type is connected to the negative pole, and N-type is connected to the positive pole. The field due to the battery is in the same direction to the internal field. The depletion area increases. The resistance of the P. Explanation. Resistance, it is the opposition to the flow of electric current. Resistance can be calculated from the relation, resistance equals potential difference divided by electric current intensity. Or, resistance equals resistivity times length divided. Explanation. Atomic spectral series for hydrogen, Balmer's series, where the electron moves down to level Ln equals 2 from higher levels. This series lies in the visible range. Paschen's series, where the electron moves down to level Mn equals 3 from higher levels. This series lies in the infrared IR range. Brackett's series, where the electron moves down to level N equals 4 from higher levels. This series lies in the IR range. Fun's series, where the electron moves down to level N equals 5 from higher levels. This series lies in the far IR and is the longest wavelengths. Question 4. 8. Mention only 2 factors affecting each of the following, then write down the mathematical formula for each. To work acting on a rectangular coil carrying current placed such that its plane is parallel to a uniform magnetic field. Question 4. Model answer. Magnetic flux density. Current intensity that pass through the coil. The cross-section area of the coil. Number of turns of the coil. The mathematical formula. Torque equals by N. Explanation. Torque. When a current-carrying coil is placed in a magnetic field, it will rotate according to the relation, torque equals BIN sin theta. Torque equals BIN. Torque equals the magnetic dipole moment. Unit of torque is Newton meter, Tesla amper square meter, Weber amper, kilogram meter power 3 per second square. Explanation. Resistance, it is the opposition to the flow of electric current. Resistance can be calculated from the relation, resistance equals potential difference divided by electric current intensity. Or, resistance equals. Question 4. Model answer. The total resistance of the circuit equals 5 ohm. The total current intensity that pass in the circuit I equals V divided by R equals 15 divided by 5 equals 3 ampere. The potential difference between the 2 points A and B, V equals IR equals 2.5 times 3 equals 7.5 volt. Explanation. Atomic spectral series. Question 5. 8. When does each of the following values become equal to 0? The magnetic flux density at a point between 2 parallel wires, each carrying electric current. Model answer. At the neutral point, or, when the direction of the current that passes through the 2 wires are in the same direction. Magnetic field. The magnetic field between 2 current-carrying wires, if the electric current is in the same direction, then, the magnetic field between them will be in opposite direction. If the electric current is in the opposite direction, then, the magnetic field will be in the same direction. Question 5. B. Mention 3 sources of energy responsible for exciting the active medium to get laser beam. Model answer. Electrical energy, either by using radio frequency waves, or using electric discharge under high DC voltage. Optical energy, either by flash lamps, or using a laser beam. Thermal excitation. Excitation by chemical energy. Explanation. Main components of a laser. Active medium. Sources of energy responsible for exciting the active medium. Resonance cavity. Question 5. From the shown truth table, deduce the kind of the gates, X, Y, and Z. Complete the table. Question 5. Model answer. The gate X is OR gate. The gate Y is AND gate. The gate Z is NOT gate. Explanation. Electronic gates and truth table, NOT gate. Explanation. Electronic gates and truth table, AND gate. Explanation. Electronic gates and truth table, OR gate. Question 6. 8. Write down only 2 characteristics for each of the following Funds series for hydrogen atomic spectrum. Model answer. Lies in the far infrared. It has the longest wavelengths. It has the lowest frequencies. Question 6. 8. Write down only 2 characteristics for each of the following lines of magnetic flux at the center of circular loop carrying current. Model answer. Straight lines, parallel lines, perpendicular to the plane of the coil. Explanation. Electronic gates and truth table, NOT. Question 4. Model answer. Magnetic flux density. Current intensity that pass through the coil. The cross-section area of the coil. Number of turns of the coil. The mathematical formula. Torque equals by N. Explanation. Coolidge tube. Question 4. 8. Mention only 2 factors affecting each of the following, then write down the mathematical formula for each. To work acting on a rectangular coil carrying current placed such that its plane is parallel to. Question 6. B. Write the equivalent unit, and mention the physical quantity used to measure each of them. 1. Cycle per second. 2. Volt second. 3. Ohm second. Model answer. Hertz. Frequency. Weber. Magnetic flux. Henry. Coefficient of induction.